Okay, so these graphs at the top show how the electric potential changes with radius. This obviously comes from the equation V equals K Q of R. So it's an inverse relationship, which is why we have reciprocal graphs. And the sign of it depends on the charge. If it's positive or negative, it could be the positive quadrant or the negative quadrant. We also need to note that the electric field strength is equal to the potential gradient. So the more quickly the potential changes, in other words, the closer the potentials are to each other, the more stronger the field, which is why the field is strong over here than compared to here. Now, how can we find the electric field strength from the top two graphs? So because it's change in V over change in R, it's the same as saying change in X on this graph, or change in Y on this graph divided by change in X. So it means it's the gradient. So if I want to find the field strength here, I'd have to find the gradient there by drawing a tangent, and then find the gradient from that, which gives me the electric field strength. Now, what about in this graph? This graph here is actually Coulomb's law. So electric field strength is equal to KQ of R squared. So it's actually inverse square relationship. So for this one, however, if I want to find the electric potential between 2 points, so let's say from here and here, because the equation E times delta R equals delta V, it's actually the area underneath this graph between those 2 points, which gives me the potential difference. Now if I want to get from the potential difference, I want to find the electric potential energy, I'd have to multiply this area by the charge that I'm moving to get the energy required to move between those 2 points. Now how do I test if this graph actually follows the inverse square law? So what can I plot to test if it follows the inverse square law? So I can do electric field strength of 1 over R squared, and that should give me a straight line going through the origin if it follows the inverse square law. I can also figure out the constant K of proportionality. So let's say in this case it's going to be K times Q, by doing electric field strength times R squared for the different values and checking if that K times Q is constant.